Welcome to the walkthrough of the specification, skeletons, and tests for Part 1 of Assignment 4B. The purpose of this assignment is to deepen your experience using Java functional programming features and integration with Java reactive streams and reactive microservices. In particular, for this assignment, you'll develop a server app that uses the Project Reactor implementation of reactive streams in Spring WebFlux to create microservices that receive images from clients and return updated images after applying requested transforms. The code you write for the server app does not have its own GUI. Instead, it's accessed by an Android client app that can either perform all image processing locally on the client device or remotely using the reactive microservices implemented in this assignment that are deployed on one or more servers. Please use this Android client app along with the unit test discussed below to help evaluate and debug your solution. The following resources may be helpful in completing this assignment. A detailed overview of Java reactive streams and a comparison with Java streams is available here, and a tutorial overview of Spring WebFlux and its support for reactive microservices based on Project Reactor appears here. Naturally, we'll cover all this material in class, which will be available in my YouTube CS253 playlist here. The reactive microservices image processing server app is packaged as a project using the latest version of IntelliJ. This app is written in Java and demonstrates many Spring WebFlux capabilities. For the purposes of this assignment, however, you only need to be aware of the following directories: source main Java server, whose main and microservices common folders contain the skeletons you need to fill in, as described below, and source test Java, which is a set of unit tests that exercise key features in the server and can be used to evaluate whether you've correctly satisfied this assignment's requirements. To compile this code, you need to use the provided IntelliJ project. You can start all the microservices that are part of this project by clicking the green Run Microservices button, or by starting each microservice independently by the IntelliJ IDE. You'll need to modify several files containing the skeleton Java code by completing the To Do You Fill In Here tasks to provide a working solution. Please don't change the overall structure of the skeleton, just fill in the To Do tasks and do not delete the To Do tags. In particular, you need to finish implementing the following To Do tasks for this assignment in the source main Java server folder: main controller.java and main service.java. Here, you'll need to complete the To Do tasks in various methods that implement an app gateway entry method for remote clients that want an image to be processed by a set of image transforms via the Project Reactor mono and flux classes. Transformer controller.java and transform service.java. Here, you need to complete the To Do tasks in various methods that implement a microservice entry point that transforms the image by applying a transform operation, thereby producing a new modified image that is then returned to the client via Project Reactor classes. Your solution should use no loops or unnecessary condition statements in this assignment, and instead use Project Reactor Flux and Mono class operators. Likewise, there should be no calls to block. Your solution will be considered correct if it passes all the unit tests and communicates properly with the Android client app. Skeleton code for this assignment is available here on my GitHub account. You can pull this skeleton code in your repository, read it carefully, and complete the To Do markers. Unit tests in the source test Java folder are provided to increase our collective confidence that your implementation is working as expected. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely on the unit tests to detect problems in the code by themselves. This assignment is more complicated than previous assignments since it requires deeper knowledge of Project Reactor and remote communication via Spring WebFlux. In particular, the asynchronous nature of reactive streams in WebFlux may take some time to get accustomed to. So please start the assignment soon and ask questions in class, office hours, and on the discussion forums. As usual, the reactive microservices image processing server app skeletons and unit tests are extensive, though you don't need to understand them all to complete your solution successfully. Now that we walked through the specification for Part 1 of Assignment 4B, let's take a look at the skeletons. We'll start over here in the main Java server folder, and we're going to look in the main folder under there, and we'll look first at the main application. So this is going to be the main entry point into these various microservices. And as you can see here, this main application is basically what's called a front-end app gateway, and it's going to forward incoming HTTP requests from clients to the microservices that are going to be part of the image crawler app. And you can read through this to find out more about how the annotations work and so on and so forth. The main point of this is that this is going to be used to kind of provide the main entry point that our Android client app will be communicating with. Let's go take a look at the main controller. The main controller is the main entry point for remote clients. This is how we're going to have Spring handle HTTP post requests via reactive programming. And this request is going to apply all the given transforms, and it'll return a mono that emits a list of transformed imaged objects. And again, you can read through the comments to see kind of how things work and how Spring works. As you can see here, there's an auto-wired field called main service of type main service. We'll look at main service in a second. And that auto-wired annotation just means that Spring will go ahead and connect those things up without you having to do it explicitly. Here is the main endpoint method that's exposed to clients. It's called apply transforms. As you can see, it takes a list of transforms, it takes an image to be transformed, and it takes a flag to say whether or not to do the transformation in parallel or not. And it returns a mono to a list of transformed images. And it's doing this as opposed to returning a flux, which would be the preferred way to do it because of some limitations with Android's handling of reactive types. It doesn't work quite as well as we might like, so this is our workaround. At some point, hopefully that'll be fixed, and then we can really truly return a flux, which is a better thing to do. But we'll return a mono to a list instead. You need to add the appropriate annotation to create a Spring WebFlux endpoint method. You have to make the appropriate type of method, and I'll let you read the comments above to see what you need to do there. It gives some hints that will make it easy to figure out what to do. Likewise, you also have to add the appropriate annotations so that these parameters are passed accordingly. So you have to use the annotations very similar to the ones that you had used for the parallel streams assignment, which I believe was assignment number 2, which used microservices, just not the ones that are reactive. Then down here in the implementation portion, you'll use the main service field, which is what was auto-wired up here, in order to call a method on the main service object that will apply all the transforms, and it'll obtain a flux stream of transformed image objects in response. And then what you'll do is you'll collect these results into a mono that intentionally downgrades the flux of transformed image objects into a mono to a list of transformed image objects. And again, that's needed for REST compatibility due to the limitations with Android. And that's what gets returned as the result of the method. You can see what comes back here. So now let's go take a look at the main service. That's really where all the action is. So the main service is going to be the one that defines the implementation methods that are called by the main controller. And this is really where all the heavy lifting gets done. Here we're also going to have a couple of auto-wired fields. We're going to have one auto-wired field called web client of type web client, and that's going to be used to direct all the HTTP requests to the appropriate microservices using some really cool magic that's handled by something known as the discovery client. And this is another auto-wired field that connects the main service to the discovery client, which is used to find all the registered microservices. And again, this is very similar to what you did in assignment 2, just using reactive types now as opposed to more conventional Java types like list or map. So you look down here, the main method you're going to have to fill in is called apply transforms. As you can see, it takes the list of transforms, the name of the file, the bytes, and whether or not to do this processing in parallel or not. And what you're going to do here is you're going to write a little flux stream that behaves as follows. You'll create a flux that's either sequential or parallel based on the parallel input parameter. So you have to know how to use various methods that are needed for that. For example, you'll need to use things like subscribe on and from iterable and so on. You'll then call a helper method down here to build the request URL for this microservice. And you can see here it's called build microservice URL. And you'll have to put that into the appropriate flux operator. And then the last thing you're going to do here is you're going to use another appropriate flux operator to send a post request to the service via the post request method, which is defined a little bit further down here. We'll take a look at that in a second. And return the resulting flux of transformed image objects back to the caller, which of course is the main controller. So there's just a few lines of code here to do these various steps, and you'll have to choose the right flux operators to make this work properly. I provide you with the implementation of build microservice URL. It's a little bit subtle. You have to implement the get transform microservices method As you can see here, this method will make an API call to a discovery method on the discovery client, and it'll get a list of all the registered microservices and then convert it to a flux. That should be very simple. This is just a one-liner. And then you'll take that flux, you'll filter things out so that you only have the one name of the microservice that corresponds to the transform you're trying to apply. And then you're going to go ahead and create the redirect URL for this transform microservice. This, again, is some magic using the Eureka Discovery client that we're not going to go into in a lot of detail here, but it's really cool. And since there's only one element here, because we only filtered out the one that matched, you'll return the first and only element by using the next call. So that'll be something you'll use up here. And then the last thing you'll do is you'll end up calling post request with the appropriate flux operator. And you can see that post request is going to take the URL where you're sending it, the image bytes, and the file name. And it does some cool magic. First, to create a multi-value map containing the image file name and the bytes. And so that's how you make the map. And then you go ahead and add the appropriate elements here. And I gave you this code. I wouldn't expect you to figure this out. It's not too complicated, but it's not really the point of the assignment. So we've got ourselves this map now that is going to contain the name of the file and have the bytes that we're going to be processing. And then here's where you have to do the really cool part. You have to use the web client to post the request to the designated URL, passing the map and the body of the post request. And we'll talk about how to do that in class. Then you retrieve the response from the microservice, convert the body to a mono to a transformed image object, and then return this object back to the caller as the result of this particular post request method. So it's getting back a mono to a transformed image. So that's really the part where you're going to have to think about how you make those calls. It's pretty much boilerplate once you understand the basic pattern, but you'll have to take a look at some of the examples we're going to talk about in class to make sense of this. And the other thing you have to do, of course, is write the code up here using the flux with the appropriate calls to the operators. So that's the main controller and the main service. The other thing you have to implement here is actually pretty much identical to what you had to do for assignment number 2. You have to go in and implement the transform controller and the transform service. And you'll see that these are some common code that's factored out for the grayscale microservice, the sepia microservice, and the tint microservice, which all end up using the same controller. They just work for different kinds of elements. And here's what the transform controller looks like. This is going to be how the microservice will transform or provide or perform a particular image transform, creating a modified image that will then be returned to the client. So each of the different microservices, grayscale, sepia, tint, and so on, are going to be implementing this same basic logic. So here's the transform controller. It's auto-wired to a transform service, like we had done with the main controller and the main service, really pretty much the same pattern. You have to add the appropriate annotations here to make this apply transform. Notice the singular, not the plural, apply transform method work properly as a Spring WebFlux endpoint method. Put the appropriate annotation there. You can read up here to figure out what that annotation should be. It's pretty straightforward. And then again, you also have to put the appropriate annotations on the parameters that are passed here. And then what you do in this method is you use the service field to call a method in the transform service class that will apply the transform via the microservice and the transformed object. And this will then you'll get back the transformed object as the result of that call. And then this transformed object will be converted into a mono that's returned to the caller, because we're returning a mono to a transformed image, because we're doing everything using the asynchronous based approaches with reactive types. So you'll have to figure out how to do that. And there's a couple of helper methods here: get image name from multi-part file and get image bytes from multi-part file, which you can do to get the appropriate parameters to call into the transform service. Here's transform service. So the transform service is what's actually going to perform an image transform operation. This has an auto-wired field that connects to the transforms. Here are the transforms. This is actually the code that performs the various image transforms. So you can see this is just image processing code. Don't worry too much about the details. I've provided that for you. We're going to do the same kind of trick we did in assignment 2, where we're going to have a map that maps the name to a function that performs the transform. So you have to go ahead and initialize that map here in the constructor for transform service, and then apply transform is really what's going to do the work. And again, you have to use the transform map that's defined up here in order to be able to find the function that's associated with the given transform, and then apply the transform on the buffered image. And then you'll create and return a new DTO transformed image. And if you poke around, you'll see some helper methods that'll do these things for you. So this is just kind of the image processing code. This is really very, very similar to what you had in assignment number 2. And this part really hasn't changed. What has changed, however, is the way the controller works, where we now have these reactive types as opposed to what we had before, where we didn't have reactive types. So that's the thing that's changed in this particular implementation. So that's basically walking through the skeletons you'll need to fill in for assignment number 4B, part 1. Now that we've walked through the specification and skeletons for part 1 of assignment 4B, let's go ahead and run the unit tests. If you come down here in the test, source test Java folder, you'll see how you can do this. As usual, you go ahead and run the tests. And what this is going to do is go ahead and instantiate the tests. That'll take a little bit of time to compile everything, and then the tests should begin to run. You can see now that the tests are beginning to run. We're testing the transform controller, and we're also testing the main controller, and we're testing the transform services test and the main services test. They're both black box and white box tests being run here. And as you can imagine, since this is my master solution, everything works quite well. But make sure that your code also gets green check marks for everything too. If you watch part 2 of the video on assignment 4B, you'll get a chance to see how to run the entire application, starting the server and also starting the client, and then having the client send requests to the server, which does the processing and returns the results. So I won't show that here because we haven't talked about the client yet, but please go ahead and watch part 2 of the video.